This video describes the design, manufacture, and testing of the new Accu-Sled R rotating carriage. The vertical front plate on this carriage rotates from 90 degrees to 45 degrees and is used for the lengthwise slicing of boards at an angle on the bandsaw. The rotating carriage was designed for the slicing of staves for segmented wood turning on the bandsaw. In total, this video is about 30 minutes long. Here is the time index should you wish to jump forward to a particular section in this video. Hello, I'm John Manier from Accu-Slice. In this video, I'll be describing a new carriage I just designed for the Accu-Slice system, in which the front plate rotates. In two recent videos, I was making these staves for making some segmented stave wood projects and cutting these staves on a bandsaw. And in making these staves, in order to get the angle, I actually had to tilt the table on a bandsaw. And this is a little bit cumbersome to do. The table's pretty big, and trying to get that table at accuracy of better than a tenth of a degree took a little bit of finagling to get it accurately adjusted. It was doable, it just took a little bit of time and effort to get it adjusted. So I thought there's probably a better way to adjust it. Rather than tilt the bandsaw table, why not have the carriage tilt? Now a normal carriage, these carriages are set at 90 degrees. I have my roller bearings that ride on my rail, and this front plate, both on this 12-inch carriage as well as our Accu-Sled 2 carriages with the L brackets, all are at 90 degrees. But I want this front plate to rotate. So I went back to my Fusion 360 software to design a new carriage for the Accu-Slice system. And in this carriage, I have my base plate, which is the same type of base plate. In fact, this is an 18-inch long base plate with roller bearings that ride on the rail. And then between my bottom plate and my front plate, I put a piano hinge. So this enables this front plate to rotate very freely. And then at the end, I have these slotted cams here that lock it in position. So once you set your angle, you can lock it in position so it stays in that position. And this is, in this case, I'm using this with my standard sacrificial fence with some offset cams so I can clamp my board in place to cut the board on the bandsaw. So when I work with this system, I set it on the bandsaw table, get my bandsaw blade set to 90 degrees, and then adjust my angle on the sacrificial fence here, and then lock it in place once that angle is accurately set. So this worked pretty well, and I actually made most of these staves using this carriage, and it worked pretty well. And I was all ready to start manufacturing these to get some inventory in our stock for our website so customers could purchase this system. So I actually went and ordered some hinge material. And when the hinge material came in, most of it was pretty good, but a couple pieces had some slop in the hinges. And that just isn't good enough. That hinge material has to be pretty accurate. If you have any slop in that hinge, it's going to move on you when you're cutting your board. So I went back to the drawing board, and I came up with some new hinges. And these hinges are called friction hinges. They're small hinges, but they're very, very tight-fitting hinge. In fact, you can see I have these offset clamps loose now. It takes a little bit of effort to move this. I mean, it's not an easy moving hinge like you see on a lid on a box. It takes a little bit of effort to move that, which is what you want. You want a nice, tight-fitting hinge with very little or no lateral movement in the hinge itself. So these work quite well. So this is the design we'll be using going forward for manufacturing systems for use on the bandsaw. So this is a hinge. Again, it works the same way. You tilt it, adjust your angle, and then lock it in position. So in this video, we'll be describing, how I made these systems, all the machining that went into this, because these are all custom made in my shop, and then we'll show, how it works, and actually showing it cutting some staves for some projects I'm working on. I designed this new rotating carriage assembly using the Fusion 360 CAD/CAM software. All the components for this unit needed to be machined on my CNC mill. So I used the software to not only design the system, but also to create the G-code program to machine all the parts on my mill. The carriage is 18 inches long, which will enable the slicing of boards up to 24 inches long. The bottom plate contains 5 roller bearings, which enable the carriage to slide on the Accu-Slice rail. In this initial design, a piano hinge joins the bottom plate to the front plate and enables the front plate of the carriage to tilt to angles up to 45 degrees. These hinges were later changed to friction hinges for greater accuracy. 2 slotted plates enable the carriage to rotate and then be locked in position with 2 thumb screw nuts. On the front rotating plate, I added 16 holes to permit the attachment of different sizes of sacrificial fences. This assembly drawing shows the complete assembly and the exploded view of the components. There are quite a few components that need to be machined for this system, and I'll briefly describe the machining of some of these parts. This section of the video is sped up and heavily edited to reduce your viewing time. The two main plates for the rotating carriage are machined from 4-inch wide by 18 inches long by 3/8 inch thick aluminum. These parts are first of all surface milled to provide for flat and parallel surfaces on both sides of the plates. I then use the center drill to mark the position of each of the holes that will need to be drilled into the plates. A series of drills are then used to drill these marked holes to the required dimensions. Some of these holes will later be tapped for mounting screws. Here I'm using a 1/2 inch end mill to machine the holes for the roller bearings on the base plate. After the bottom plate was machined, I then machined the front rotating plate in the same manner. Here I'm machining the slotted plates for the locking mechanism. I first drilled 3/4 inch holes into the plate and then used the 1/4 inch end mill to machine the slot into the plates. I also needed to machine the small L brackets for the locking mechanism, which were not filmed for this video. I will briefly demonstrate the assembly of the components. I attached the piano hinge to the bottom and front plates using some 1/4 inch screws. As I mentioned earlier, this hinge has now been replaced with new friction hinges, which are very tight and provide for accurate movement of the front rotating plate. Next, I attached the 4 L brackets to the bottom and front plates using some 1/4 inch screws. The slotted plate is then attached to these brackets using a 1/4 inch screw for the base plate attachment and a 1/4 inch thumb screw to make the slot in these plates to the top L brackets. The front rotating plate now rotates smoothly and can be locked in place with the thumb screws. I'm describing the construction of a sacrificial fence for my new rotating carriage. This sacrificial fence is not included with the rotating carriage that we'll be marketing in the near future. I started off by drilling some 25/64 inch diameter holes for the 1/4 inch 20 TPI brass screw inserts. I drilled these holes using my CNC mill, but they can also be drilled on a drill press, or if you're very careful, they can be drilled with a hand drill. By using my CNC mill, I was able to accurately space the holes 300,000 of an inch apart. I next screwed the brass inserts into each of the holes using an insert adapter for my hand drill. This adapter is available on Amazon or from McMaster-Carr. And here's the finished sacrificial plate with all the brass inserts. Now I have used this style with these sliding pieces, but what I found happens quite often when I'm putting a lot of pressure, these move. They hold pretty well, but not as tight as these screw-in inserts. So these are nice because they're adjustable, they're easy to adjust, but they just don't quite hold as much pressure as these do. And with these, it's particularly important that they don't move on me, so I'm trying to make sure they get real tight. But I have used both of these. Sometimes I use this and sometimes I use this. But I made this special for this rotating sled, and I made these holes. The distance between the holes is 300,000, so there's 300,000 between each of the holes. You can do boards from probably about a 1/2 inch thick up to like probably 2.5 inches thick. The other thing I did, I took an 1/8 inch pin and I drilled an 1/8 inch hole in the bottom here, and I use that as a stop. Because again, another thing I found in fact you can probably see it here, as I'm putting the board in, it's actually moving. But by putting a stop there, it doesn't move, and I get a more accurate clamping of the board. Just got to make sure that it doesn't get in the way of your bandsaw blade. I just developed some new tapered screw-style offset cams for use with a rotating carriage. These new offset cams will be described in a new video, which will be posted next week. For this new style offset cam, instead of having a flat perpendicular surface on the edges of the offset cam, the bottom edge is first tapered by 5 degrees, and then the top edge is tapered at an angle to provide for a screw type of movement as the offset cam is tightened. This geometry of the offset cam forces the board being clamped tightly against the sacrificial fence and provides for more accurate cutting of the boards on the bandsaw. I developed the techniques to manufacture these new tapered screw-style offset cams on my CNC mill, and it will be fully described in a new video, which I plan on producing next week. Okay, I made two other minor changes to the system. Since my sacrificial fence extends beyond my carriage, I had to cut some slots in the sacrificial fence. Let me pull it off, you can see those. So you can see the slots I had to cut here so the bracket clears. I did it on both sides. The other change I made is I cut off the last 1/4 inch of my cleat on the bottom. And I'll show you why I needed that. I needed a flat straight edge here. I also added 2 knobs here. Probably need a little bit bigger knobs, but these are just to hold the system to slide it. I tried using both of these small angle meters, and I was having trouble with them. They were jumping around a lot and moving a lot. So I really didn't think too much of them. So I went back to using my digital angle gauge here, which I think works better. So the first thing I did is I put my gauge on my bandsaw blade, try and get it perfectly straight, and then zero out my gauge. Then, because I cut that cleat off the bottom, I can put this gauge right against the sacrificial fence and measure the exact angle. And that's measuring 20.1 degrees right now. So I can adjust it a hair just by loosening this clamp up and just twisting it a touch. I got exactly 20.0 degrees on my angle gauge. And I can move the carriage to the other side and measure the angle on the other side. And I got 20.4 here, so I can raise this up a hair just by loosening it and twisting it a touch. There's 20 degrees right on the button. Blade is set up, and the angle between my board and my blade is exactly 20 degrees on both ends of my carriage. So I'm using now, I cut some MDF boards 1 inch wide, and so let me make some staves out of this, see how it works out. So again, what I'm doing, I'm pushing it down against the stop in the back, against the cleat, tight against the fence, and then tightening my clamps. And these MDF boards are about, probably 20 inches long. So next I'll go cut these into segments 2 inches long, and then we'll piece them together and see how they look. Okay, I did that first test, and I do have some gaps here, some significant gaps. So this is probably a good idea using MDF to do my testing. It's a lot cheaper than using some of the good wood. So what I need to do now is, I have a gap on the outside, so I need to take more off the inside. So I need to increase my angle. And we can change the angle slightly. So there's 20.5 degrees. Notice here I am activating the mag jig clamps, because if you don't activate the mag jig clamps, you could get an error in your angle. Well, that test came out better, but I still have a little bit of a gap. But it's better than the previous one. But I think I'm going to take off a whole degree. It's 21.5. It was definitely much easier adjusting the fence to adjust the angle rather than adjust the bandsaw table. And there's 21.5. Okay, that third try at 21.5 degrees worked perfect. So this is probably a good idea, using MDF as a scrap piece to dial in your angle. Now once they're all set, then you can go and do a good piece of wood. In fact, I have a really good piece of wood I wanted to run, so let me go ahead and run that. This is a laminate board I made several years ago, and it has 13 layers of wood, alternating colors. And I'm going to be cutting this across like this. What I'm going to do is I'm going to cut a board, and I'm going to take that piece I cut off and put it back on here and cut it again. So both boards will be the exact same size. That way I'll get the most use out of this board. And I have two different boards. So I'm going to go cut this into 18 segments. I figure how long they're going to be. And then we'll put them together. But what happens when this gets turned down, to show you real quick, when this gets turned down, these different layers will show up, especially as you do curves in and out. And there's that resulting set of 18 segments. And this is the final assembly after glue up, in which I put maple spacers between each of the segments. I just mounted the new version of the rotating carriage on my Accu-slice Index table, and this is the version with the friction hinges. And I'm also using these new style offset cams with the tapered and screw type geometry on the offset cams. So I'll be using this level to adjust the angle on my rotating carriage. So I start by putting this level against my bandsaw blade. It has a magnetic base, and I can attach it to the blade behind the teeth of the blade. And you can see the angle is reading a little less than 90 degrees. So what I'll do first of all is I'll zero that out. So now it's reading 0. And then I can put this same gauge on my fence, on the sacrificial fence, and I have it adjusted to exactly 20 degrees. Then I can adjust if I need to, look, it's reading, 0.05 degrees over. So it reads pretty accurately for measuring the angle of the sacrificial fence. And I can adjust it with my thumb screws here to get the exact angle. Much easier adjusting it using this than adjusting the bandsaw table. And I also adjust the angle on the opposite end of the sacrificial fence. And I took a piece of MDF and I made some segments, and when I put it together on the first time they came out perfect. And this was a perfect joint on those. There's no gaps at all between those wedges. So that was just luck or what on the first try, but I set my angle to exactly 20.00 degrees and it seemed to work perfect. So next I'll be running some boards. I have some yellow heart and some walnut boards, and I'll be making some staves that are probably about 4.5 inches tall. I'm just going to demonstrate how I attach the board to the sacrificial fence using these new style offset cams. And so I have the cams adjusted to the right size, and I can put my board on here. So what I normally do is I loosen the screws on these cams, maybe just a quarter turn, just so they slide easily, so they're smooth movement on all of them. So they're not real tight, so it's maybe an eighth to a quarter turn, pass finger tight. And I put my board on here. And then what I do is I tighten both ends. I just push the board against the fence and then tighten the clamp slightly. Do that on both ends and in the middle. And the taper on these offset cams forces the board towards the fence. You see there's almost no gap between them. So I do tighten it up a little bit more. Then as a final step, I tighten the screw, and that pulls it in even more. So that is really tight against the sacrificial fence now. So it's actually, being screwed twice against the sacrificial fence. And now there's actually no gap between the board and the sacrificial fence. That's as tight as you can get it. It's almost like it was glued and clamped in place. And that'll give you real nice, accurate cuts for the system. So between the angle being set accurately and the board being securely fastened to the carriage, the sacrificial fence with no gaps, you should get nice cuts on your board. Here's a close-up shot of the walnut board attached to the sacrificial fence with these new offset clamps. And you can see the gap between the walnut board and the sacrificial fence is basically non-existent. It's a perfect tight joint. So let me adjust my position that I want to cut. I want to get a little bit larger wedges for this project, and make sure I lock my mag J clamps. In one of my previous studies, I forgot to lock the mag J clamps, and the angle came out wrong. So it's important that mag J clamps get snapped tight to the table. But these new style offset cams work great. You see the geometry on these. But this is like a taper, like a screw. And when you turn it, it actually pulls the board against the sacrificial fence. Then I remove that board from the fence and put the next board on the sacrificial fence and just loosen these offset cams, probably looks like 1/8 of a turn on the screw. Not a whole lot, just 1/8 of a turn is all I need. And then I clamp the board in place, the offset cams, go back and tighten the screws once again, that 1/8 of a turn. And that board once again is tight against the sacrificial fence. Well, I cut those walnut and yellow hard pieces in about 4 3/4 long staves and assembled them together. And I grouped them with a rubber band to hold them in place. And here's the resulting. Pretty good, near perfect on all the joints. So this system worked quite well. It was actually quite easy to adjust using that new level to adjust the blade and the carriage. So that worked nice. And this new offset cam with the tapered edges worked really nice to pull that board flat against the sacrificial fence. So I got really nice cuts with it. This concludes this video on the new rotating carriage for the Accu-Slice system. There will be some additional videos coming out in the near future on the use of this system for making some stave projects and probably some other angular projects. And there'll be a video next week on these new tapered screw type offset cams for the Accu-Slice system. These work quite nicely, and there'll be a video on this next week on our website. In developing the rotating carriage for the Accu-Slice system, I was debating whether to have this mount on top, like our Accu-Sled 2 carriage, or have its own carriage with rollers on it. And I decided to go with a separate carriage with its own rollers on the base of the system. And doing this, the boards will be closer to the bandsaw table, and I just felt it'd be more accurate for cutting the staves with the system. This is a new rotating carriage which replaces a prototype version, which I described earlier. I made 2 changes to the system. First of all, I went to these friction hinges, and also I added handles to the system. But that was the only 2 changes I made to the system from the prototype version. The prototype version worked quite nicely with the piano hinge, but I just felt that these friction hinges would work actually much better. I tested a number of angle meters to get the angle of the rotating carriage. I first tested these small angle meters, but I felt they were just too small to get an accurate reading on the bandsaw blade, and they tended to jump around a lot when I was adjusting the carriage. They were just too hard to use, and it was very hard to read the meters when it was at an angle. So I next used this digital protractor, and this worked quite well for measuring the angle. And I used this in the testing of the first prototype version. However, when I developed the second version of this rotating carriage, I discovered this larger digital level, which I found to be easier to use in measuring the angle of the bandsaw blade, and also when adjusting the angle of the rotating carriage. Since the level is longer, I get a more accurate reading of the angle of the bandsaw blade. The base of the level is magnetic, so I can attach it to the bandsaw blade behind the teeth on the blade and then zero out this gauge. Then I use the level to accurately measure and adjust the angle of the rotating carriage. I was able to adjust the angle of the front plate on the rotating carriage to an accuracy of better than 0.05 degrees. I found this level to be the easiest method of measuring and adjusting the angles on this rotating carriage. And this is a gauge I plan to use for all my future projects using this system. In adjusting the angle of the rotating carriage, I measured and adjusted the angle on both ends of the carriage. After adjusting the angles, I then locked them in place using the thumb screws on the slotted plate on each side of the rotating carriage. The ability to measure and adjust the angle on both ends of the carriage will ensure accurate cuts with this system for the entire length of the boards being sliced. The design of these offset cams forces the boards against the sacrificial fence due to the screw-like geometry on the edges of the offset cams. These tapered offset cams work quite well, as I just demonstrated. When I tighten these cams, they pull the board tight against the sacrificial fence with no gaps between the board and the sacrificial fence. What worked out great was using some scrap MDF to tweak in the angles for the wedges, as I demonstrated during the testing of the prototype version of the rotating carriage. As I demonstrated, it may be necessary to tweak the angle in small increments, as small as 0.1 degrees, in order to get perfect segmented wedges with no gaps between the wedges. This was quite easy to accomplish with this adjusting rotating carriage. During the testing of the second version of the rotating carriage, and when using a new tapered screw-style offset cams, and also using a digital level to set up the system, I was able to get perfect angles on my wedges on my very first attempt. However, I still recommend testing with some scrap wood or MDF to verify the accuracy of the angles. After I had the system correctly adjusted, I was able to slice my board to get perfect segmented projects. The slotted brackets with locking thumb screws work quite well for locking both ends of the carriage. Being able to adjust the angle on both ends of the carriage and then lock both ends in place assures an accurate angle of the entire length of the carriage and the boards being sliced. Also, make sure that you lock the mag jig clamps before using the system. When the mag jig clamps are activated, they actually pull down the Accu-slice system about 0.1/10 of an inch, which may be enough to cause an error of less than 1 degree if they're not activated. On one occasion, I forgot to activate the mag jig clamps, and my angles on finished product were off. My preference for using the system was to use a sacrificial fence with the brass screw inserts. Although I've used a sliding system for the offset cams in the past, it does not work quite as well as the brass screw inserts. I just feel that the brass screw inserts are better when a lot of pressure needs to be applied to the board with the offset cams. However, the sliding system for attaching the offset cams are adjustable and it's much easier to use to adjust for various board thicknesses. So I'll probably be using both types of systems in the future. I did have one minor issue with using the brass screw inserts. After I drilled the holes and inserted the brass screw inserts, I noticed that the surface around the brass screw inserts was raised slightly. Apparently the pressure of the screws going in forced the MDF to swell up slightly, and this gave an uneven surface. As a result, I had to take some sandpaper and sand down the surfaces, and then I actually took the sacrificial fence and ran it through my board sander to get it perfectly flat. This cleat on the bottom of the sacrificial fence was made from a scrap maple board that is about 3/16 of an inch wide at the top and then tapers down to 0 at the bottom. It was made from a 1/4 inch square by 24 inch long maple board and then glued to the bottom of the sacrificial fence along its bottom edge. After its first use, the bottom edge was cut off at the same angle as the boards I was cutting. I also did put a stop at one end of the sacrificial fence. This does help in making sure that the board does not move during clamping, but this is not really necessary. In fact, I actually removed this pin when testing the final version of the rotating carriage in order to slice some longer 24 inch long boards. The rotating carriage design is quite sturdy and heavy and is a very accurate system. It's very heavy since it's made out of 3/8 inch thick aluminum plate. These aluminum plates were machined flat during the construction of the machining of these plates. The bottom plate has 5 roller bearings on its base that are adjustable and enable the system to ride on the Accu-slice rail. There are 16 small holes in this front mounting plate for the attachment of the sacrificial fence. Having this large number of holes permits the attachment of almost any size sacrificial fence. In conclusion, this final version of the rotating carriage worked quite well. It's definitely much easier to adjust the angle from the boards being cut using this rotating carriage as compared to rotating the table on the bandsaw. I plan to use this system for many additional projects in the future, including some stave projects, and I'll be looking for some other applications for other angular type projects. I just finished machining an initial lot of 4 of these systems to put in inventory, and I have material in order to produce a larger batch for the next run. The system will be fully described on our website, both the rotating carriage and its new offset cams, and so it'll be available for purchase in the near future. Once again, thank you for watching this video. If you have any questions or concerns or comments, as always, please give us a call or drop us an email. We're always happy to hear from you.